Now that we know how to find the value of a definite integral, we can learn some interesting theorems, and one of those interesting theorems is the mean value theorem. The mean value theorem. And the mean value theorem says if f of x is continuous over an interval a, b, we should be used to seeing this by now, then there exists one point at least, there's some c in AB such that f of c is equal to 1 over b minus a integral of a to b f of x dx. We can say the integral from a to b f of x dx is equal to f of c multiplied by b minus a. Now let's think about what we mean here for a second. We have f of c equals 1 over b minus a multiplied by the integral from a to b of f of c dx. This is a little confusing, so let's think about this in terms of summations. What is the average value? If you have a bunch of test scores, let's say you have a bunch of test scores in a set A, where A equals 100, 95, maybe you had a tough one, 60, and let's say, I don't know, 83. Let's say you have all of these values, and these are A values, and you wanted to know what your average grade for the class was. Well, you would take the sum from I equals 1 to 4 in this case of our AIs. And in fact, let's fully abstract this. Let me erase the 4. Let's say we're finding any random grade from I equals 1 to n of AI. That's the sum of the grades. And you would divide by n. You would divide by the number of grades. That's exactly what we're doing with what we have boxed up here. These two things mean the same thing, except one is the discrete version and one is the continuous version. Because what we see there is we're taking the integral from a to b of f of x dx, which we know is a sum, it's an infinite sum, and then we're dividing by b minus a. b minus a is that range. And so what we're finding with this is we're finding the average value. C in this case is going to be, f of c in this case is going to be the average value of our function. So let's do an example. Our example is going to be find the average value of f of x equals 8 minus 2x over the interval 0 to 4. And then we'll find c such that f of c is the average value. Awesome. So we have our formula. F of c is equal to 1 over b minus a integral from a to b of f of x dx. And let's just start plugging things in. Our interval from a to b is 0 to 4. Our f of c is equal to 1 over 4 minus 0 from 0 to 4. F of x is 8 minus 2x dx. And this is a definite integral that we now know how to solve. So what I'm going to do is I'm going to integrate. This is equal to 1/4. Integrating 8 gives me 8x. Integrating negative 2x gives me 2x squared over 2, or just x squared. And this is going to be on the interval from 0 to 4. And we have 1/4. We have to plug in our 0, which just gives me 0. That's easy. Plugging in our 4 gives me 8 times 4 minus 4 squared, which is equal to 1/4 times 32 minus 16. 32 minus 16 is 16, divided by 4 is 4. And so we have 4 equals that f of c. Now, we know our function is 8 minus 2x. So now we know 4 is 8 minus 2c. Subtract 8, I get negative 4 equals negative 2c. Divide by negative 2, and I get c equals 2. So our average value here is 4, and the c that gives us that is exactly c equals 2. And so what does that mean? Well, we have this function. We're going to from 0 to 4, and this function is 8 minus 2x. F of x equals 8 minus 2x. And if I graph this function, at 0, we're at 8. At 4, we're at 0. And for example, at 2, if I plug in 2, I get 8 minus 4 is 4. At 2, I get 8 minus 4 is 4. Which gives me this point here, and if I draw the line through it, that's my function that I have. And so what we're finding is the average value of the function is that point right there. So, for example, this is a cool result. If I draw the rectangle that goes through that point, what's the area of my rectangle? The area of my rectangle is going to be 4 times 4, which is 16. And what's the area of the function under the curve? The area of the function under this curve is, in fact, we already found it, but it's 4 times 8, which is 32, divided by 2, because this is a big triangle, which is 16. 8 times 4 over 2, which is 16. And so the area of the rectangle under the point, that's the average value, is going to give me the function's average value, it's going to give me the function's area under the curve, which is really interesting. So that is the average value of a function. That's the mean value theorem.